Correct V-belt tensioning is the single most important factor necessary for long, satisfactory belt operation. How you tension a belt at installation will determine how long the belt will run. Too little tension results in slippage, excess heat, premature belt failure, pulley wear, and lower bearing life. Too much tension results in excess stress on belts, bearings, and shafts. However, there still is a wide range of tension at which a belt and bearings will operate satisfactorily. It is critical to understand that tension loss occurs on all manufacturers' belts. The highest quality belts will lose nearly 50% of installed tension, while lower quality belts lose over 70% of installed tension. Most of the tension loss occurs in the first hour and day of running. You will need to install a belt such that it retains enough tension to provide long-lasting, trouble-free operation. You cannot feel the correct tension on a V-belt. All belts do not feel the same when properly tensioned, due to different materials and tension cables used in their manufacturing process. On a test given to 250 experienced maintenance personnel, only 2 of the 250 tensioned a belt correctly using the feel method. Many were as low as 7% of the proper tension. To accurately tension V-belt drives, the most widely used and a simple method is the force deflection method, which we are now going to demonstrate. You will need a tool such as a best torque tension pencil to simply measure the force and to deflect the mid-span of the belt a given amount. First, we need to determine the 2 numbers we need to use the tool, P and F, on this diagram. Measure the span length of the belt P, which is the distance from where the belt touches one pulley to where it touches a second pulley, or roughly the center-to-center distance of the 2 shafts. In this demonstration, it is 12 inches. This span length in inches is put into this simple equation to determine the amount of deflection. You deflect the belt 1/64th of an inch for every inch of span. In this case, it is 12/64ths of an inch, which is simplified to 3/16ths of an inch. Next, you need to set the deflection distance F, in this example 3/16ths of an inch, on the tension pencil O-ring by sliding the O-ring on the body of the tension pencil. Then you need to set the second O-ring to its 0 position on the pound scale on the plunger by sliding the O-ring down the plunger until it touches the yellow stop ring. Then we'll demonstrate taking a reading on a single belt drive. To obtain this reading, you will need to place a straight edge across the top of the belt. Place a tension pencil in the center of the span of the belt and slowly push down on the rubber knob on the tension pencil until the O-ring is lined up with the edge of the straight edge. Now that we have deflected the belt the recommended amount, the top O-ring will have moved up the plunger, and that shows us the amount of force used. In this case, we have a measurement of 11 pounds. If you have a multiple belt drive, you will only need to tension the loosest belt. You will need to simply deflect the belt until the O-ring is in line with the top of the adjacent belt. The belts will need to be somewhat tight already to ensure that the adjacent belt is straight between the 2 shivs. We need to compare this reading to the deflection force charts. These can be found in the Best Torque Installation and Maintenance Guide, Product Information Brochure, and specific Best Torque tensioning flyers. This information can also be found online at www.besttorque.com under Belt Installation and Maintenance. To find the correct deflection force on the chart, you will need 5 pieces of information. First, we are using BX belts. Second, the smaller outside diameter is 4.4 inches. Third, the speed is 3550 RPM. Fourth, we are using Best Torque cog belts. Fifth, these are new belts. Using the information, the deflection force should be around 9.1 pounds. We have 11 pounds. The belt will lose the installed tension in a very short period of time, normally in the first 10 revolutions. The tension will decrease 10 to 20% depending on the belt type and drive conditions. Optimally, you would tension the belt to a reading 20% over the table amount. in this case 11 pounds, realizing if you do this you will not need to come back to retention. The loss is due to the simple fact the belt is made of rubber and it will conform to the pulley groove and seat in the groove. The tension will continue to decrease for the life of the drive due to seating in and belt wear, eventually declining to 40–50% of the installed tension. Belt life varies greatly depending on how the belt is tensioned at installation. When installed at 100% of the correct tension, the belt life will be extremely good. Looking at the graph, you can see that the tension is only 20% at installation. The belt life can be very low. If you choose to install the belt to the exact amount as in the table or a little less, it is recommended to come back in 1 hour and also at 24 hours to check the tension and set it to the force shown for a new belt. If the elapsed time is 48 hours of running or more, use the amount shown for a used belt, realizing that a reading by over up to 25% is acceptable. A reading of less than shown for a used belt will lead to belt slip and lowered belt and bearing life. At each preventive maintenance interval, if the belt tension is checked, it should be at the used belt force or up to 25% above. Belt tensioning also affects bearing life. When a belt is loose, it will slip, causing excess heat. This leads to hot bearings and lowered belt life. Installing at the optimum tension will keep belts from slipping. Bearings are also designed for this load. The bearings will actually run cooler and longer to the lower heat buildup from belt slip. We have performed repeated trials to verify this fact. In a typical trial, the bearing temperature was 124 degrees Fahrenheit at the recommended installation tension. Even when the belt was initially tensioned to 3 times the recommended amount, the bearing temperature remained at 124 degrees Fahrenheit. Note that when the belt was installed loose and started to slip, even just a small amount, the bearing temperature rose quickly. At 5% slip, the bearing temperature had rose to 178 degrees Fahrenheit.